All right, I'm going to work a few problems with you from your gas laws worksheet. And the first one I'm going to do is number 1A. So it says, correct the following gas volumes from initial conditions to the new conditions. Assume that the pressure or temperature is constant if it's not given. So for letter A, you are given 45 milliliters. So that's your initial volume. Because remember, it says we're converting each of these from initial conditions to final conditions. And they're saying at 49 degrees Celsius to negative 29 degrees Celsius. So they're saying your initial temperature was 49 degrees Celsius, but your new temperature is negative 29 degrees Celsius. So we're supposed to be solving for new conditions. So if we already have the initial volume, but we don't know the second volume, that must be what we are solving for. So nothing has been mentioned about pressure. That's because pressure, we're assuming, is constant in this example. So try to remember, what rule did we learn about that only deals with temperature and volume? Remember, Charles watches TV. So this is Charles's law. So that's V1 over T1 equals V2 over T2. Now, before we start just plugging in numbers to this equation, you need to remember that your temperature needs to be in Kelvin. So we need to add 273 to both of our temperature problems. So here we get 322. And here we get 244 Kelvin. All right, so now I'm going to plug this into my equation. 45 milliliters over 322 equals V2 over 244 Kelvin. And you have options here. You can either cross multiply, or the way I would do it is I would divide 45 divided by 322 and multiply by 244. Whatever works for you. If you want to do cross multiplication, then it'll be 45 times 244 equals 322 V2, and then you just divide both sides by 322 to get V2 by itself. 45 times 244 divided by 322, we end up getting 34.1 milliliters. All right. Now, a good thing to do for these problems is to check to make sure your answers make sense. If the temperature decreased from 322 to 244, what would we expect the volume to do? Since the volume and the temperature are directly proportional, if temperature decreased, the volume should also decrease. So the fact that we saw 45 go down to 34, that answer makes sense. All right, so that's just an example from problem number 1. I'm going to move on now to problem number 2 and work that with you. So it says an unbreakable meteorological balloon is released from the ground. Ground level pressure is 98.5 kilopascals with a temperature of 18 degrees Celsius. The balloon contains 74 liters and 14 moles of hydrogen gas. As the balloon ascends, the pressure drops to 7 kilopascals. If a temperature drop of 79 degrees occurs, what is the new volume of the balloon after the temperature change? Okay, so we're given a lot of information here. Let's try to make sense of everything. So this balloon starts from the ground. So the initial conditions are what we're given about the ground. Ground level pressure, that's going to be P1, is 98.5 kPa. Ground level temperature is 18 degrees Celsius. It says the balloon contains 74 liters and 14 moles of gas. All right, well, if you look further on in the problem, there is nothing else said about moles. This is the only thing they have said in the problem about moles, which means that's just kind of superfluous information that we really didn't even need to know to solve the problem. So I'm going to put that in parentheses, 14 moles, but it's not something we need to solve the problem. However, I do need to write down my initial volume because the point of the problem, the purpose, is to solve for the new volume. All right, so what is my new pressure? What is P2? So as the balloon ascends, the pressure drops to 7 kPa. And notice the wording here. If a temperature drop of 79 degrees occurs. So they're saying that the temperature dropped by 79 degrees, because it wouldn't make sense going from 18 to 79. That would indicate that the temperature went up. So we're actually going to take 18 minus 79. And you get negative 61 degrees Celsius. And then the question says, what is the new volume? All right, well, you might have noticed we have all three variables for this. So this is going to be the combined gas law, which is P1 V1 over T1 equals P2 V2 over T2. Any converting we need to do before we begin. My pressure is okay. The first one's in kilopascals, so is the second one. And remember, for Boyle's law, Charles, Gay-Lussac combined, your pressure can really be in any unit. It just needs to be the same unit. Same thing for volume. Our answer should be in liters because the other volume is in liters. But Celsius needs to be in Kelvin, always. So we're going to add 273 to both of our temperatures. Okay, now we're ready to plug in stuff. So I'm going to move down here. 98.5 times 74 over 291 equals 7 times V2 over 212. Again, you can cross multiply, so that would be 98.5 times 74 times 212 equals 291 times 7 times V2. And then divide both sides by the 291 times 7 to cancel those out. I'm sure you are great with algebra, but just in case, I wanted to show my work there. 98.5 times 74 times 212 divided by 291 divided by 7. And we get V2 equals 759, which if you look at your original volume, it's 2 sig figs. I'm going to round that to 760 milliliters. Okay, so again, checking our work, if the pressure went down, we expect the volume to go up, and it most certainly did. So that's number 2. All right, the last one I'm going to do with you is number 6. All right, so for number 6, it says a sample of gas occupies 300 milliliters of STP. How many moles are in the sample? Now, I know earlier for number 2, I ignored moles because it was obvious to me that since they've given us initial and final conditions, that we didn't need this number. But if you're ever given a problem where you're not given 2 sets of conditions, you're only given one, and the amount of gas is mentioned in the problem, then you're going to need to use the ideal gas law. So that is Pivnert. All right, so in this example, it says STP. Remember that that is standard temperature and pressure, which is 1 atmosphere and 273 Kelvin. So plugging in for P, do that here, that's going to be 1 atmosphere. For volume, remember that your volume for the ideal gas law needs to be in liters. So you need to move your decimal to the left 3 places. So that's 0.3 liters. Equals N, which we don't know. That's the point of the problem. How many moles are in the sample? Your ideal gas law constant is 0.0821. And then my temperature is 273 Kelvin. So now I'm just multiplying 1 times 0.3, dividing it by the ideal gas law constant, and also dividing it by 273. Let's see what we get. 1 times 0.3 divided by 273 divided by 0.0821. And I get N equals 0.0134 moles. Now, technically, the only number we were given in the problem only had 1 sig fig, so the real answer, rounded to the correct number of sig figs, would just be 0.01 mole. All right, so those are the only problems I'm going to work with you, but do keep in mind that the answer key is on Google Classroom, so I would look at that if I were you as you're working through these, and let me know if you need any help.